Okay, here we're going to demonstrate how flow-through vacuum works. Basically what we do is I've already laid down my gasket relative to the size of my workpiece. From here, the next step I need to do is remove the washers for the vacuum ports. Now it's important to remember as a time-saving feature here that you don't need to remove any more vacuum port plugs than equal the size of your supply hose. In this case, for me to remove any more than 2, maybe 3 plugs would be a waste. So when you get into bigger sheets and bigger applications, this could save you some time removing and reinstalling the plugs. Okay, so we've got our plugs out. Now, as a add-on here, just for a little more security and stability, I'm also going to use our grid locator plugs, which means I'm going to need to pop out 3 more washers. What we'll do is we'll replace those with our locator plugs. Basically, they just have an extra seal and they protrude above the top of the table. Now, I've got my piece of water-resistant MDF here. Get it at any lumber yard. Nothing special. All we've done is put some masking tape around the outside edge to help seal up against vacuum loss. So we'll take our board. This is also referred to as a spoil board. We'll locate it against our 3 locating pins, apply the vacuum. Now you can see the board is securely held in place. I can actually feel the vacuum being drawn right through this board. From here, we take our piece of sample material here. This piece is being held to the spoil board by a vacuum being drawn right through this board. And again, as you can see, it's held quite well. Now here you can see we've actually cut channels in our spoil board to lay gasket. The gasket protrudes just slightly above the surface. We've also cut some shallow vacuum channels in the board and popped a few holes to allow vacuum to flow even better. Here we're doing nested base machining on a 1/2-inch sheet of plastic held in place only by a vacuum drawn through the spoil board.